Okay, hi and welcome to the first lecture in the suddenly online version of this course. So if you remember where we're up to, we got to lecture 10. That was going to be the start of week 4 of teaching, and the topic was going to be repetition and loops. So that's been moved forward 1 week. So we're sort of running a week behind schedule at the moment, but don't worry too much about that. We have plenty of space in the course to fit everything in. So my plan really is to, rather than just me talking for an hour and recording it, I want to break up this recording into smaller parts, and the parts will roughly correspond to each topic. So the idea is for each lecture you'll be able to watch a shorter video and then have a break and then come back and watch some more, and then have a break and then come back and watch some more. So that's the plan so far. And what I need to be able to do is move to the next slide. So the topics hopefully that we would have covered by the end of the series of videos for this lecture are listed here. We're going to be looking at some new types of operators, plus, plus, and minus, minus, and then we're going to be focusing on 2 main types of loop, which are the for loop and the while loop. And at the end we'll briefly talk about some new C# controls that you can use in your programs. So I already introduced the track bars and the track bar control in the previous videos, so if you haven't seen those, go and have a look at them. They're pretty interesting, and they're some useful revision for stuff that we've done in the first 3 weeks of the course. So let's get into it. Why do we need loops? Well, the main reason for using loops is that it enables the computer to do the same thing over and over and over again so many times. So far all we've been doing is writing simple programs where we start from the beginning, we go through a series of steps and we reach an end point, and each step is only done once. Okay, so that's fine. We can write programs that do that kind of thing, but they're relatively simple. So you could actually just use a calculator to do a lot of the things that those kinds of programs do. What we really want to be able to do is do calculations on a massive scale. So we write the same instructions, but we do the same thing, but then we set them up so that we can repeat them over and over and over again, maybe millions or billions of times, and that's where the real power of using a computer comes in. So here's some pseudocode just showing how you might go about writing pseudocode that contains instructions that need to be repeated. We've got a really simple example. So this one is adding the first 10 numbers. Okay, so imagine that you had to write a program to add 10 numbers together, and you got a piece of paper like you're supposed to do and sat down and tried to figure out what the pseudocode was for that program before you sat at the computer and started typing the C#. So let's take a look. There's 2 ways of doing it. You could write 11 statements on your piece of paper. So the first one would be to set the total to 0, and then the second statement will be to add the first number to the total, then add the second number to the total, add the third number to the total, and so on until you add the 10th number to the total. Okay, so that's a fairly long sequence of pseudocode instructions to write down. Or if you're a bit cleverer and you don't like writing so much, you could write something like this. So set the total to 0, so we start with 0, and then repeat the following 10 times, add the next number to the total. Okay, so it's far less to write, and it makes use of the idea that you can repeat the same instruction over and over and over again. Okay, so add the next number to the total is the instruction we're repeating. And the power of this approach comes when we need to add 10,000 numbers or 1,000,000 numbers or 1 billion numbers. Okay, so you can't really write down 10,000 or a million or a billion lines of pseudocode like this. You wouldn't want to do that. It would take you a very, very long time. It would kind of like being in trouble at school where you've got to write lines. Instead, you'd want to do something like this, where you replace the 10 here with 10,000 or a million or a billion, and then your program is, or your pseudocode is much easier to write. Before we get into how we actually do loops in C#, we need to cover different ways of modifying variables. So we have already talked about some of these methods before, but so some of this will be a bit of review, and then we're going to introduce some new methods of modifying variables. Modifying variables is very, very important for programming loops in C# because you need to know when you're going to stop. And we use variables for that, and that means that we need to modify the variable all the time. So let's take a look at these. This is an example here. We've got two variables, I and j. I is set to 53, j is 105, and we've got an assignment statement. And if you remember how assignment statements work, whenever you see this equals sign, what you do is calculate what's on the right hand side of the assignment. So the right hand side is j minus 10, and then that's an expression. So the result of that is sent across to the left hand side. So what we're saying is the expression j minus 10, j is 105, so j minus 10 is 95. 95 gets sent across to I. So i's value, which used to be 53, gets updated to 95, and we can see that over here. Here's the situation. 95 goes into this box. Okay. Here's a similar situation. This time, rather than using two different variables, we're using one different variable. And we have seen this before, but we'll look at it again. The idea here is to update i's value depending on its current value. So the expression is I minus 10. I currently has a value of 53. So this gets evaluated and then sent across to the left side, which is I, and so 43, the result of the expression, gets put into the variable I. And we can see that here. Often when we write loops, we want to count how many times we've done a loop. So for example, in the pseudocode before, we wanted to add 10,000 numbers. In order to add 10,000 numbers together using a loop, we need to have some way of counting how many numbers we've added so far. So we need to know if we're up to number 9,001, so that we can then do number 9,002, number 9,003, and so on. And we also need to know when we're up to number 9,999, so we know when we're about to finish the loop, because once we reach 10,000, that'll be the end of the loop. So C# provides various ways of adding 1 to a variable. That's a very, very common operation, and they're shown here. We've got a assignment statement like we've been looking at before, I equals I plus 1. That should be straightforward. But then we've got two different ways of writing the same thing, just in a shorter-hand way. So the first one is I plus equals 1, okay, which just means add 1 to I. It's exactly the same as this. And then an even shorter version called I plus plus, which again just means I equals I plus 1. So these three statements are all equivalent. And that's very, very important, because you'll see this plus plus statement is used all over the place. So you always see I plus plus in different places. This is sort of an intermediate between this version and this version. The main difference here is that you can change the number. So sometimes you want to have your variable increasing by something else that's not 1, such as 2 or 3. So you can change the number here. For this one, it only lets you increment the number by 1. And the opposite, sometimes we want to count down. So we want to start with a number like 10,000, then go to 9,999, then 9,998, and so on all the way down to 1. Well, we can do that with these three statements. So these are doing exactly the same thing as the statement we just saw, but they're subtracting 1 instead of adding 1. And again, down here we've got I minus minus, which is a very, very shorthand way of saying decrease I by 1. Okay. And decreasing a variable by 1 is also called decrementing. So you'll sometimes hear the terms incrementing and decrementing. They just mean adding 1 or subtracting 1. And so now we come to the point where we can introduce the first loop. So the for loop in C# has a special syntax. It's a bit different to what we've seen so far. Well, in fact, it looks a bit like an if statement. So with an if statement, we have if and then expression and then a body of code. That happens if the if statement is true. With the for loop, we do something similar. We have for, but then this is not an expression. Instead, we have 3 statements, and we can see they're separated by semicolons. They're not all expressions. One of them is an expression, but 2 of them are not. And then we have the body of the loop. So this is the part that's going to be repeated over and over again. So any C# statements that you put in here will get repeated. So let's have a look at the body of the loop. So it starts off, the first part is a statement. The second part is a condition, which can be true or false. So this is in fact an expression. And the third part is the thing that we do on each iteration of the loop. So we're going to go over those 3 parts individually in turn. For your information, this loop executes 7 times. Okay, so num is going to be our main counter, and num is going to have the values 4, 5, 6, 7, 8, 9, and 10. And you can see that there's a 4 in the top part of the loop and a 10 in the top part of the loop. So they specify, these numbers specify where the counter starts and where it ends. And we can see that num takes on all of the values between 4 and 10, and so it's going to execute this loop body, this block of code here, 7 times. Okay, so let's have a look at the individual parts of the for loop. So the first statement there is what happens at the start of the loop. This only ever happens once. So that's a key point. This is what's done to set the loop up. So this is what this example is saying is that there is a variable num which has to have a value of 4 initially. So at the start of the loop, num is set to a value of 4. Okay, and that only happens once at the beginning of the loop. The last part inside the parentheses there is what happens on each iteration of the loop. So this is called a so in this case we're incrementing num by 1. So the idea here is that this statement executes on every iteration of the loop. So remember that this one is only happening at the start of the loop. This one happens on every iteration of the loop. So what this is saying is every time the code inside here executes, and it's going to be 7 times, remember, then increment num by 1. Okay, so num will start at 4. We do the first iteration, then num increases by 1 as shown here. We do the second iteration, then num increases by 1 again, so num is now 6. We do the next iteration and so on until the loop stops. This is the condition. Okay, so the idea here, and it sort of sits right in the middle, so I've explained the first and the last part of the for statement. This bit sits in the middle. This tells us when to end the loop. Okay, so this is like the beginning of the loop and setting up. this is what happens on every iteration of the loop while the loop's running, and this is how the computer knows when to stop the loop. And the idea here is that the loop stops when this expression becomes false. So if you remember from previous lectures, we can have, there's a certain data type in C# called a Boolean, which can have only two values. One is true, one is false. And if we have a relation like this, less than or equal to, this produces an expression which returns a Boolean value, true or false. So what we're saying here is that if num is low, like it's 7 or 8 or 9, then this expression overall returns true. But if it's high, such as 10, or actually 10 will return true. If it's high, like 11, then this value returns false. So the idea with this part of the for loop here is that as soon as this expression is false, the loop ends. Okay, so the loop keeps going as long as this part here is true. Okay, and it's going to be true when num is 4, 5, 6, 7, 8, 9, and 10. When num hits 11, it's going to be false. If num is 12, it'll be false. If num is 13, it'll be false. But it's not going to get that far. It's only going to get up to num being 11. As soon as num becomes 11, this is false, then the loop ends and we do whatever is in our program under here. Let's look at an example where we can use a loop. So this is calculating the factorial of a number, and you probably have done this in school, but if you haven't or you've forgotten, then here's a refresher. We write the factorial in math with the exclamation symbol. So this is saying 5 factorial is defined as 5 times 4 times 3 times 2 times 1. So it's just a product of all the numbers from 5 down to 1. And if we had 10 factorial, that would be the product of all numbers from 10 down to 1. So for 5 factorial, the answer is 120. So let's think about how we might write a program with a for loop that calculates the factorial of any number. So there's a bit of pseudocode here. So first step in the program, obviously we need to get the input from the user. So that's going to be the number n. So the user gives you a number n, and the computer program is going to calculate n factorial. So we get n from the user. Then we set the value of factorial n. So this is going to be a new variable that's going to store the result. So we set that value to be equal to n. Okay. And then we repeat for values of num. So we're going to go through each of these in turn in a loop. So if n is 5, n minus 1 will be 4, n minus 2 will be 3, n minus 3 will be 2, and n minus 4 will be 1. So we're going to repeat for each of these values here, but we're pretending we're starting with n, so we don't know what n is. It could be 5, but it could be 10, or it could be 100. So we're going to repeat for values n minus 1, n minus 2, n minus 3, and so on, all the way down to 1. And what are we going to do inside the loop body? So inside the loop body, we're going to say factorial n equals factorial n times num. Okay? Well, maybe it's clearer if I just highlight bits as I talk about it, because I'm not sure how easy it is to see this mouse moving around. Okay, so this is going to be the loop body. After the loop's finished, we should hopefully have the final result. So factorial n should contain the factorial of n. And so the last step there is to report the calculated value. Let's turn this into C#. So let's start up here. We are going to get the number n, so that's our input, and we can see that that's happening down here. So we've set up a text box that contains num, and we're parsing that into an integer called n. Okay, that should be straightforward. Next step, we set the value of factorial n equal to n. Okay, so Here's our input. This is going to be our final result. And when we turn that into C#, we get this assignment statement here. So int factorial n equals n. Now we do a for loop. Okay, so here's the pseudocode for our for loop, and here's the translation of that pseudocode into this first part of the for loop. Okay, so what we can see here is that we're setting up a variable called num, and we're assigning a value n-1. So that's here. So that's the start of the loop. So num starts at n-1. We're going to run the loop while num is greater than or equal to 1. Okay, so we're going to actually count down in this example. We're starting from n-1. We're going down to 1. As soon as num hits 0, this expression will be false. But as long as num is greater than or equal to 1, so 1, 2, 3, 4, 5, so on, it'll be true. And here's the update that occurs on every iteration of the loop. So we decrement num by 1 on each go. Okay, so that's the sort of the header part of the loop. Now let's look at the body. So the body is defined here. And inside the loop, we want to do factorial n equals factorial n times num. And if we have a look at that, the translation of the pseudocode into C# is here. We have to have the curly braces here just to indicate that this is a block of code, and then the code inside that block is indented. And we can see that it says factorial n equals factorial n times num, which is just a direct translation of this statement here. And finally, we output the result. Okay, and we can see that, yeah, we're just using a message box here, so we're just outputting n. And you might have picked up while I was doing that example that I haven't used try catch around here. So when you come to do this example, if you give it a go, then make sure you put a try catch around the pass to make sure that the user is forced to enter a number. Okay, so I'm going to stop there, and on the next video we'll look at the while loop, which is a different type of loop.